and ignore the line K in the middle like we did on the other proof, we'll see that 1 and 6 are alternate interior angles between lines J and L. So if we prove that J is parallel to L, like in the last proof, same exact steps, same exact 3 steps. The final step, we can say that angle 1 is congruent to angle 6 because they're alternate interior angles, while ignoring line K completely. But I'll be using angles for this proof to show you how we can use different ways, different methods to prove the same thing. Okay, so let me do a 2-column proof. And the first step, I'll be writing the given. And the first part of the given is talking about line J and line K, and those are parallel. And in the steps on the attached paper, I started with angle 1 and 5, saying those are alternate interior. Well, we don't have to go that route. We can conclude 1 and 2 are corresponding again, like the first time we did the proof for question 3. We can do 1 and 2 corresponding, 1 and 5, alternate interior. We can do really that proof in many ways. So I'll be starting with 1 and 2 corresponding again. And then line K is parallel to L, that's the second given. And for that one, I'll be using alternate interior angles. Between K and L, we have 2 and 6 are alternate interior. So again, for the first proof, we could have done it in many ways, like 1 and 5 alternate interior, 5 and 3 alternate exterior, and then conclude 1 and 3 congruent for the first proof. So we didn't have to go with corresponding angles only, although that's what we did. We didn't have to. So you can conclude any types of angles. You just have to be wary of the fact that we're trying to include angle 1 and angle 6 somehow. So if I want to do 1 and 5 alternate interior, then I can say 5 and 6 are corresponding for lines K and L, then use 1 and 6 in the transitive like I wrote on the worksheet, which you can pull out. But for that case, well, I started with 1 and 2 corresponding angles. And then for lines K and L, I'll say that angle 2 is congruent to angle 6 because they're alternate interior angles. And I'm noticing that 2 is in common, and that's the congruency statement. 1 is congruent to 2, 2 is congruent to 6, 2 is in common, and those are congruency statements. So for that case, I can conclude that angle 1 is congruent to angle 6 because of the transitive property. Again, there are many ways to do those proofs. We could have even, instead of 1 and 2, we could have even went with 4 and 2 alternate exterior angles. Then 2 and 6 alternate interior, so we could have changed that step. Instead of 1 and 2 corresponding angles, we could have said 4 and 2 alternate exterior. But we have to be wary. What are we trying to reach? We're trying to reach angle 1 and angle 6. So really choosing 4 and 2 will not help us necessarily get to 1 and 6 in an efficient way. So even though you can use any of the 5 angles that we learned in chapter 3, you have to just be very smart about which angles you can choose to work with in the proof so that we get to the final conclusion that they asked us to reach. I hope that is helpful, and you can ask me more questions in class. We'll do more practice, but the worksheet that I attached is very important, and I really want you to study that one really hard. And if you have questions about it, just let me know and I'll help you out. All right, thanks.